It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project. Figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000, from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
NASA has some incredible plans for the moon. For example, their next ambitious lunar program, Artemis II. They've set their sights on landing astronauts, including the first woman and the next man, on the moon by 2024. Artemis is all about building a sustainable presence on the moon. They're planning to establish a lunar gateway, a sort of space station in lunar orbit, which will serve as a jumping-off point for lunar landings. And let's not forget about the cool lunar landers. Scientists are developing the mighty Space Launch System rocket, which will launch the Orion spacecraft carrying astronauts towards the moon. Then there's the Human Landing System, a snazzy lunar lander that will gently touch down on the moon's surface, allowing astronauts to explore and conduct amazing scientific experiments. And NASA isn't going alone this time. They're teaming up with international partners, like the European Space Agency, to make this lunar dream a reality. But all these wonderful dreams might be ruined by something that seems super small and insignificant at first. Picture this: no atmosphere, no air to breathe, and suddenly, a mysterious haze and radiant beams of light appear at sunrise and sunset. It's as if the moon is putting on a celestial show. But there is a twist to this beauty. During the Apollo 17 mission in 1972, this beautiful sight made one of the NASA astronauts, Harrison Schmitt, sneeze and made his eyes water. He called it lunar hay fever. This mysterious fever affected all 12 moonwalkers. From sneezing fits to stuffy noses, those astronauts experienced symptoms as if they caught a cold. It took days for the reactions to fade away. This event led to a discovery about lunar dust and its darker side. When scientists found out about these rays, they rolled up their sleeves and delved into their origins. And here's what they discovered. Those radiant bands of light were actually caused by sunlight sneaking through layers of teeny tiny lunar dust. The dust was composed of small particles and sharp glass shards, and was lurking everywhere. And it turned out that this lunar dust was a sneaky villain. It brought a whole host of problems. Astronauts who found themselves with impaired vision were just the beginning. The troublemaker went even further, damaging precious machinery and causing electronic malfunctions. It even had the audacity to corrode components and smelled like burnt gunpowder inside the spacecraft. Yikes. It clings to everything, coating surfaces like a mischievous blanket. It can clog up equipment, get into delicate machinery, and even mess with astronauts' spacesuits. In 1972, things got really hairy again. The Apollo 17 astronauts faced a nightmare. After just 22 hours of gallivanting on the lunar surface, their spacesuits suffered irreparable damage. Yes, you heard that right. Irreparable. The dust diminished astronauts' mobility, making it harder for them to move around and perform their moonwalks with grace. And no matter how hard they tried to clean it off, it clung on for dear life, leaving the spacesuits in a sorry state. So, as you can see, it poses some serious challenges for future moon missions. But our intrepid scientists aren't giving up. To solve this problem, they have to understand how lunar dust forms and why it's so darn clingy. They found out that it all begins with meteorite impacts. When these space rocks crash into the moon, they generate a fine dust that fills the air. Sometimes these impacts even cause minerals to melt, forming sharp glass shards that mix with the dust. Talk about a moon makeover. The dust is also filled with silicate, a material commonly found on volcanic planets. Silicate inhalation can cause serious lung problems for Earth's miners, so you can imagine the trouble it can cause on the moon. A recent study found that even a scoop of replica moon dust was toxic enough to destroy up to 90% of lung and brain cells exposed to it. But it gets worse. The low gravity on the moon allows those tiny particles to float around for much longer, penetrating deeper into the lungs. Imagine breathing particles 50 times smaller than a human hair for months. That's a recipe for trouble. And you see, on the moon's surface, things are a bit different than here. There are no rainstorms or strong gusts of wind to blow this dust away. There is also no atmosphere to protect the surface. So without the natural forces of wind and water erosion like we have on Earth, these dry particles stick around persistently. And to make matters more electrifying, the moon is constantly showered by radiation from the sun. This exposure gives the dust an electric charge. The solar winds create positively and negatively charged particles. The particles then buzz around, repelling each other and giving rise to those radiant bands of light that the Apollo 8 astronauts witnessed. It's like a disco party on the moon. ESA, the European Space Agency, has gathered a team of experts to study the lunar dust. They're working with simulated moon dust mined from a volcanic region in Germany to understand its behavior and effects. Engineers also need to find a way to protect future astronauts and equipment. Engineers in NASA want to create spacesuits that can survive not 1, not 10, but a whopping 100 extravehicular activities on the lunar surface. That's like spending 800 hours out there, exploring and having a blast. Besides that, NASA initiated the Breakthrough, Innovative, and Game-Changing Idea Challenge in 2021. It was open to clever university students from all over the world. These young minds put their thinking caps on and unleashed a wave of innovative solutions. For example, they proposed using special fibers that conduct electricity, inspired by fluffy chinchilla hair. Just like how chinchillas stay dust-free, these fibers would help keep the lunar dust at bay. A furry friend lending a helping paw, isn't that adorable? Another bright idea involved an electrically charged brush activated by UV radiation. It's like a magical wand that zaps away the dust with a flick. Abracadabra, lunar dust be gone. And let's not forget the fabric inspired by clever insects. These insects have pollen-collecting structures that repel unwanted dust. So our ingenious students thought, why not mimic that? They designed a fabric with similar properties, creating a shield against the sneaky lunar particles. What's remarkable about these ideas is that they all use the power of charge to fight the dust. They cleverly repel it from the spacesuits, keeping them clean and protected. And even though all these ideas sound pretty great, scientists in NASA unleashed another, even better solution: carbon nanotubes. It's a great way to revolutionize spacesuit fabric. What makes these carbon nanotubes so special? Well, they possess some amazing superpowers. First off, they're superconductive, meaning they can carry electricity like nobody's business. It's like having a lightning bolt trapped inside a microscopic tube. Not only that, but these carbon nanotubes are tougher than the toughest meteors. They have the strength to withstand the harsh lunar environment, where even a speck of dust can cause trouble. Imagine having a suit made of a material that's stronger than Superman's cape. So, NASA's scientists decided to weave these extraordinary carbon nanotubes into the spacesuit fabric. The electrodes were carefully integrated into the outer layer of the fabric, making it a force to be reckoned with. But how do they banish the lunar dust? Well, here comes electrifying science again. When activated by a special alternating current, the electrodes create powerful electric fields. These fields work like magnets, repelling both charged and uncharged dust particles away from the spacesuit. Picture this like a dance party, where the dust particles are the uninvited guests, and the electric fields are the bouncers, swiftly escorting them out. Thanks to this technology, lunar dust doesn't stand a chance against our astronauts. Also on the bright side, the lunar soil can be used to make bricks for shelters. It can also help extract oxygen for astronauts to survive on the moon for long periods of time. When life gives you lemons, make a lemonade, right? So, let's cheer on our NASA Dream Team as they embark on this epic lunar quest. Let's hope that they succeed in their findings, and the next moon mission won't be a big problem. Stay tuned. Count how many times the word moon is said in this video. Enjoy. There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonates, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't submoons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile-wide submoon could only survive moving around a 600-mile-wide moon on a wide separation orbit, if these parameters are not met. The tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic, galaxy-sized black holes.
The moon has always been a source of wonder, myth, and mystery. It lights up our nights, controls the tides, and marks the rhythms of time. But what if the moon isn't what it seems? What if this familiar, glowing orb in the sky is not a natural object at all, but a hollow, perhaps even artificial construct? That's the central idea behind the hollow moon theory. A concept that blends science fiction with ancient lore, and dares to question everything we think we know about Earth's closest celestial neighbor. Let's explore the bizarre clues and strange stories that fuel this unsettling possibility. During the Apollo missions in the late 1960s and early 1970s, NASA astronauts left behind scientific instruments, including seismometers. In 1969, the Apollo 12 crew intentionally crashed a portion of their spacecraft onto the lunar surface. The result shocked mission control. The moon reverberated for over 50 minutes. Scientists said it rang like a bell. This was not a one-time event. Later impacts during Apollo 13 and 14 produced similar results. Long-lasting, deep seismic vibrations that were unlike anything observed on Earth. Some theorists argue that this behavior could be a sign that the moon is hollow or has vast inner cavities. After all, nothing on Earth behaves that way unless it's mostly empty inside. NASA's explanation is more conservative. The moon has a dry, rigid crust with little water content, which allows seismic waves to travel much farther than they would through Earth's moist, fractured interior. Still, the Bell effect remains one of the strangest lunar anomalies on record. In many ancient cultures, there are legends of a time when there was no moon. Aristotle mentioned that the Pelasgians, the ancient people of Arcadia, lived before there was a moon in the heavens. The Zulu people of Africa tell stories of two brothers, Wawane and Mpanku, who brought the moon to Earth, an artificial object, hollow and controlled, which changed the weather and caused great floods. Ancient Sumerian texts also hint at a celestial object that arrived unexpectedly in the sky. These accounts span multiple continents and civilizations, alluding to a world that once turned without a moon. Are these myths simply poetic metaphors? Or could they be distant memories of real events passed down in the only language available to ancient humans, myth and story? The moon is the fifth largest natural satellite in the solar system, and by far the largest relative to the size of its planet. No other moon comes close in size ratio. This alone makes Earth's moon an outlier, but there's more. The moon is precisely the right distance from Earth, about 384,000 kilometers, to perfectly cover the sun during a total solar eclipse. The sun is 400 times larger than the moon, and also about 400 times farther away. This perfect 400 to 400 ratio creates an extraordinary visual phenomenon that allows scientists to study the sun's corona during eclipses. Coincidence? Maybe. But to some researchers, it feels more like design. And then there's the moon's orbit. It's almost perfectly circular, and it's tidally locked, meaning we always see the same face. We never see the far side of the moon from Earth, unless we send spacecraft around it. Why does this object behave so precisely? Is it a natural product of gravitational forces? Or something else? In 1970, Soviet scientists Mikhail Vasin and Alexander Sherbakov published a radical paper titled, "Is the Moon the Creation of Alien Intelligence?" They suggested that the moon may be a colossal, ancient spaceship, an alien construct disguised as a natural satellite. According to their hypothesis, the moon might have a metallic outer shell with an inner structure that once supported machinery, life, or monitoring equipment. They compared it to a planet-sized arc that could travel between star systems. While their paper was largely dismissed in the West, it planted the seed for countless other theories. Could the moon be a derelict alien spacecraft? Long abandoned, perhaps watching us still? More recent fringe thinkers have proposed even stranger ideas. Some argue that the moon might not just be a passive structure, but a kind of anchor for a simulated or controlled reality. In this vision, the moon is not just hollow, but alive with technology, possibly operating as a monitoring station, memory regulator, or even a civilization reset button. Ancient floods, magnetic pole shifts, and unexplained disasters. Some theorists claim these events correlate with specific lunar alignments or cycles. Others go further, suggesting that the moon is part of a larger system designed to keep human consciousness limited, trapped in cycles of forgetting and rediscovery. Is the moon helping to shape our very perception of time, reality, and evolution? It's impossible to prove, and perhaps that's the point. Even beyond the big theories, there are many small puzzles that don't quite fit. For example, when scientists first studied moon rocks, they expected to find thick layers of accumulated dust, possibly several meters deep. Instead, the moon's surface dust was surprisingly shallow. Where did all the debris go? Radio signals sent to the moon sometimes bounce back with strange delays, suggesting interior reflections that aren't typical for solid rock. And then there are the mysterious transient lunar phenomena. sudden flashes, glows, or color changes on the moon's surface. These have been observed by astronomers for centuries, yet remain unexplained. Mainstream science sees the moon as the product of a massive collision in Earth's early history, a fragment of the young planet that cooled into orbit. But for every answer science provides, there seem to be more questions. Why does this object behave so perfectly? Why do myths around the world speak of its arrival? And why does its presence feel so scripted? Whether you believe in the hollow moon theory or not, one thing is certain: the moon is far more than just a rock in the sky. It is a mirror to our imagination, a beacon to our ancestors, and maybe, just maybe, a puzzle we were never meant to solve.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about a third of a ton of rock and soil from our satellite. These samples showed that Earth and the moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the moon would be the same as on Earth. But they are a bit different. The moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the moon's formation these days is the giant impact model. Meteorites coming from the moon are a great source of data for studying the origins of our satellite too. They can tell us even more about the moon than Apollo samples, all because such meteorites come from all over the surface of the moon. Meanwhile, Apollo samples were collected just in one place near the equator on the near side of the moon.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago, but they appear much younger than expected. Typically found in clusters of 10 to 40, they're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the moon. In its early years, the moon was just a molten world, shaking from intense volcanic and seismic activity. So, the moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the moon, but for Earth too. After all, the giant impact that formed the moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the moon's continued activity. As it cools, the moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria, See these large, dark patches on the moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the moon actually affect humans? In a sense, it can. The moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the moon's surface, grinding much of it into powder. Unlike Earth, the moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the Moon is made up of layers, a crust, mantle, and core. However, the Moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The Moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the Moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the Moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the Moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the Moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the Moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the Moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the Moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the Moon's gravity as they go. It's like they were feeling the Moon's invisible pull in different places. If the Moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the Moon, even if they can't actually go there. And the spacecraft intentionally crashed into the Moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the Moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The Moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the Moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the Moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the Moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the Moon itself, it also tells us more about other celestial bodies. If the Moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the Moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up. Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night. And suddenly, there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon. But then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in two from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the SOFIA telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the moon. These places have never seen light, and the water there might be encased in ice. But SOFIA found water on the sunlit surface of the moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the moon. But an even more unusual phenomenon is happening there right now. The moon is actually rusting, just like a piece of old metal. For rust to appear, we need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago, but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city, but heavier than the sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did this zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now, normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space: thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or "that's a really big cow." It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.
Imagine you could travel through the universe by hitching a ride on space dust, meteoroids, comets, or even rogue planets. Wouldn't it be incredibly cool? This idea is known as panspermia. It has captivated minds for centuries, but despite its appeal, it hasn't gained much popularity among mainstream scientists. Mainly, it could be because it doesn't explain how life originated and isn't easily testable. At the same time, certain events have reignited interest in the theory, even among skeptics. And one of such events was the appearance of the mysterious Oumuamua in our solar system in 2017. Oumuamua was a mysterious object that zipped through the solar system at an astounding speed. It was the first interstellar object spotted passing through our star system and the first detected hyperbolic asteroid, an object with an orbit not bound to the sun. Observations indicated that Oumuamua was likely to be a highly elongated cigar-like object. Overall, it was a very unusual object. Scientists couldn't quite pin down what it was. Some of them suggested it was a comet, others bet it was an asteroid, and there were those who thought it might be a chunk of frozen hydrogen. In April 2020, astronomers presented a new possible scenario for the object's origin. According to one hypothesis, Oumuamua could be a fragment from a tidally disrupted planet. If true, this would make Oumuamua a rare object of a type much less abundant than most extrasolar dusty snowball comets or asteroids. What made Oumuamua especially interesting to those who support the panspermia theory is that it was a visitor from another star system, so it was possible that it could have carried life across the galaxy. The idea of panspermia advances 3 stages: escape from a planet, transit through interplanetary space, and landing on another planet. Therefore, the Oumuamua hints that panspermia is possible. Recently, a new study titled "The Implications of Oumuamua on Panspermia" has seen the light of day. It was led by David Tsao from Thomas Jefferson High School for Science and Technology, an intern at Johns Hopkins University. The study explored how many objects like Oumuamua might exist and what characteristics they would need to transport life safely across the cosmos. The researchers considered different types of space debris, such as asteroids and comets, and estimated their potential to shield life from harmful radiation, particularly gamma rays from supernovae. If these objects weren't large enough, the intense radiation would sterilize any microorganisms hitching a ride. According to their findings, space debris made of materials like nickel or silicate could provide sufficient protection. But for a passenger to survive, they would need to have a minimum size of about 21 feet. The study also tried to estimate how likely it was that extremophiles organisms that can survive in extreme environments could have been delivered to Earth in this way. They calculated that roughly 40,000 objects of at least 33 feet in diameter could have impacted Earth during its first 800 million years. While this number might sound like a lot, the chances that Earth itself was seeded by panspermia are extremely low, less than 0.001%, according to the study. Interestingly, the researchers didn't just consider Earth as a recipient of panspermia, but also as a potential source. If Earth or another habitable planet ejected life-bearing material into space, that material could, in theory, seed other planets across the galaxy. The study suggests that under optimistic conditions, up to 100,000 Earth-like planets in the Milky Way could host life as a result of panspermia. However, many factors remain uncertain. For instance, the number of rogue or free-floating planets in the galaxy could significantly affect the panspermia hypothesis. Hopefully, when we discover more about these planets and the overall density of interstellar material, we will understand more about panspermia. The scientists have also underlined that the conditions in the galaxy were different in the past. For example, during an event known as the Late Heavy Bombardment, the rate of impacts on Earth and other bodies in the solar system was 100 to 500 times higher than it is today. If similar events occurred in other star systems, the potential for panspermia would be much greater. Despite its allure, the panspermia theory remains a fringe idea in scientific circles, all because of the many unknowns and its speculative nature. But as we gather more data from projects like the upcoming Rubin Observatory's Large Synoptic Survey Telescope, which is expected to detect many more interstellar objects and rogue planets, astronomers will likely revisit and reassess this idea.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star.
A sound from space? When up there in space, no one can hear you talk, laugh, or scream. Or at least that's how the saying goes. People can't hear anything in space due to its condition. Still, If you have the right conditions, like the hot gas that surrounds the black hole located at the center of Perseus, space can be quite noisy. That's the galaxy cluster 250 million light-years away from us. Researchers caught an actual sound of space, waves rippling through the plasma gas in Perseus. They first realized black holes generate acoustic signals in 2003, but this is the first time they brought these signals to the human ear, and wow, this sounds terrifying. Canyons filled with liquid on Titan. Almost a decade ago, NASA spacecraft discovered deep canyons on one of Saturn's moons, Titan. They're about a half-mile wide and they kinda look like the Grand Canyon, but they're filled with liquid hydrocarbon. This was the first time we came upon evidence of canyons and channels filled with liquid on Titan. Our solar system is full of small particles and bigger rocks that circle the sun, the same way as planets. Sometimes it happens, some of them change trajectory, which is why falling pieces of debris strike the planets. Most of the meteorites and comets originate in our solar system. Some from the asteroid belt between Jupiter and Mars, while others come from the Kuiper belt, that's located beyond the orbit of Neptune. But 5 years ago, scientists found something unusual, a red, elongated floating space rock called Oumuamua. It could be more than 3,000 feet long, but its size still wasn't the most impressive part. It was the first interstellar object we saw passing through our solar system. It means it formed and came outside of it. It was traveling way faster than asteroids and comets from within our solar system. No one knows where this weird object came from. Many, many years ago, when it started its journey and sailed away from its parent planetary system, the stars weren't in the same position as they are today, so it's hard to pinpoint where Oumuamua ran away from. The rock could have been on its journey for billions of years. Solar termination events. Our sun is not just a flaming ball of gas we see in the sky. It's actually a pretty complex network of towering plasma fountains, magnetic fields, and blobs of unusual matter 500 times bigger than our own planet. And then there are solar termination events. When it comes to its activity, our sun goes through a natural cycle of troughs and peaks. Approximately every 11 years comes the time when the sun is more active than in other periods of the process. As the cycle goes to the end, there are fewer emissions and sunspots. That's because magnetic fields are weakened at that point, and they collide along the sun's equator. This results in enormous tsunamis of plasma. They pass across the solar surface for weeks. These are the most powerful storms in our solar system. They twist, snap, and lash out into space and seriously affect our power grid. As they wake, large spots start to form on the sun, close to strong magnetic field lines. Usually, that's when the cycle begins all over again. No one still knows why exactly they form. Also, we're not sure if this only happens at the end of the cycle, and knowing more about this could help us prepare for raging solar storms better. Tsunamis on Mars. It appears the shorelines under the Martian surface formed because of two enormous tsunamis. Mars has something that's probably the longest landslide in our entire solar system. The rocks rolled down the mountain probably billions of years ago. They fell into the water and caused a gigantic wave that rushed across the Martian landscape. As the tsunami was getting bigger, the rocks scraped all along the solid ground beneath them, and these sandy waves left their prints on the shoreline, not so close to Olympus Mons. That means it's possible the waves traveled a couple of 100 miles. This supports the theory that Mars once had an ocean hidden below its dry desert surface. Sure, Oumuamua was cool because it was the first object we've seen coming from outside of our solar system. It's past us now, so it's not possible to study it anymore. But something else came from outside our solar system after Oumuamua. A comet called Borisov. It came with a tail over 100,000 miles long. teams got the first images of Borisov in 2019. A bright white glow was surrounding it. And that was one of the first signs where scientists realized this comet wasn't from our solar system. They tried to collect as much information as possible because they remembered how quickly Oumuamua got away. Borisov came from a freezing place as cold as the Kuiper Belt. One theory says it may have originated around a red dwarf, which is the most common type of star in our galaxy, the Milky Way. But unfortunately, Borisov was also very fast. So fast that they only managed to see it a couple of weeks before it passed by our planet. By now, it's almost out of our solar system. Finding new planets is always such a thrill, just like it was in 2017, when a group of researchers discovered Super Earth. It's an exoplanet, which means it orbits a star outside of our solar system. This one has a mass almost 3 times that of our planet, and it's only 21 light-years away. It orbits M dwarf star, and it manages to make a full circle in only 2 weeks. So that's how long the year is on this planet. It's closer to its star than Mercury is to our sun. But M dwarf stars are cooler than our sun, so it's possible this planet still has water. Super Earth is generally a term for planets that are lighter than ice giants such as Uranus and Neptune, yet more massive than Earth. They can be made of rock, gas, or even a combination of both. The one they discovered in 2017 is especially interesting because this type of planet can also hold some form of life. Leroy Chow is an astronaut who commanded the International Space Station back in 2005. This one time, during his final spacewalk, some pretty unusual lights caught his eye. It looked like 5 lights flying near him. They were in the shape of a pyramid, since one light was a bit further ahead. Chow immediately called one of the crew members who was also out there at the same time, taking a spacewalk. He asked his colleague if he saw the flying objects, but apparently he didn't. Researchers were intrigued by this story, so they examined satellite images to see if that was the thing Chow saw. One of the options was that Chow had seen fishing boats off the coast of South America. With bright lights, they wanted to attract squid. But since it was twilight time, the rotation of our planet may have made them appear to fly by. Neutron stars slamming into each other. After a massive star comes to its end in a strong supernova explosion, its core falls apart. Then it forms the densest form of matter we know about in the whole universe, called a neutron star. In only a couple of the first few seconds after a regular star begins transforming into a neutron star, the energy there is equal to the total amount of light all stars in the universe emit. At least the part we can observe, which is still a lot. It's hard to determine their real size, but picture it this way. The length of Manhattan with 1.5 times the mass of the Sun. If a star here were any denser, it would just collapse and form a black hole. Scientists captured 2 of these stars colliding a couple of years ago, and such impacts are extremely powerful. They create gravitational waves that lead to a ripple in space-time, but they produce heavy elements like platinum and gold.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant, swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, These rings are made of small particles of dust rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adams rings. Scientists think that these are relatively young, much younger than our solar system and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song, because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, it has the mass of the sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT 14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while, and by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive, though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip, we're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So let's keep exploring and keep being amazed by the wonders of the universe.
In the vast expanse of the universe, there are planets unlike any we've seen before. Planets with a treasure trove of diamonds. What mysteries do these sparkling worlds hold? What do they look like? And most importantly, just how much would it all cost? Let's find out. First of all, let's take a look at diamonds in general. We see them as rare and valuable gems, but did you know that they actually come from something as ordinary as carbon? That's right, this is the same element that's found in your pencil lead or coal. This is also the key ingredient in a diamond. But how does a plain old carbon atom turn into a dazzling diamond? Well, it all starts deep beneath the Earth's surface. At depths of around 100 miles, carbon is exposed to temperatures of over 2,000 degrees Fahrenheit and pressures of over 825 pounds per square inch. That's like putting the weight of 3 elephants on a postage stamp. Under these extreme conditions, the carbon atoms bond together in a unique way. They form the crystal lattice structure that gives diamonds their distinctive shape. This process can take millions or even billions of years as the carbon slowly makes its way closer to the Earth's surface through volcanic activity. And then, finally, the diamond is formed. After that, it may stay hidden in the Earth for thousands of years until it's brought to the surface through volcanic eruptions. From there, the rough diamond is cut and polished into the beautiful gems that we know and love. So, why are diamonds so valuable? Well, it's partly because of their rarity. Only a small fraction of the diamonds that are formed actually make it to the surface. But it's also because of their beauty and durability. Diamonds are the hardest substance known to humans, and they have a unique ability to refract light in a way that makes them sparkle and shine. Diamonds also have a wide range of practical applications. They're used in cutting tools, grinding wheels, and even in the tips of surgical instruments. And thanks to advances in technology, scientists are finding new ways to use diamonds in fields like electronics, energy storage, and medicine. All this goes to show that sometimes the most extraordinary things can come from the most ordinary of elements. Now that we know this, let's get back to our diamond planet. Can planets like this even exist? Actually, yes, they can. In fact, we come across diamonds in space much more often than on Earth. In space, extreme pressure and temperatures are very common. That's why the universe, and even our solar system, is actually incredibly wealthy. Your regular asteroid can cost millions of dollars. Helium, which we can find almost everywhere in space, has a huge energy potential. It's not surprising that humanity has been discussing the possibility of space mining for some time. Now, as I mentioned earlier, diamonds are formed deep within the Earth under conditions of extreme heat and pressure. Scientists believe that a similar process could occur on a planet that's rich in carbon. There are a few possible ways it could happen. For example, when 2 planets or asteroids that contain a lot of carbon collide with each other. The collision would create a shockwave that would push the carbon atoms together so tightly that they would form a diamond. The second way it could happen is if this region of space contains a lot of carbon. If the conditions are right, then the carbon atoms would come together and form a planet-sized diamond. It's like if you have a lot of Lego blocks and you put them together to create a big Lego structure. In other words, if 2 carbon-rich objects collide with each other, the carbon atoms can be squeezed together so tightly that they form a diamond. And now, surprise, surprise, these planets actually do exist. The planet we're talking about is called 55 Cancri e. It's one of the 5 planets in a small system in the constellation of Cancer. Its star is actually so bright that you can see it with the naked eye. It's located 40 light-years away from us, which may be trillions of miles, but on a space scale, it's pretty close. 55 Cancri e was first discovered in 2004. However, we didn't learn until 2012 that it was the first known diamond planet. All thanks to the research of scientists from Yale University. This planet is the super-Earth. This is a class of planets that are larger than our Earth, but too small to be considered giants. It's about twice as big as our Earth and about 8 times heavier. The planet rotates around its star really fast. It completes a full turn in just 18 hours. This means that 1 year on the planet is less than a day on Earth. It's also tidally locked to the star. In other words, one side of this planet is always turned towards the star and therefore is incredibly hot, while the other is in eternal darkness, just like with our moon. Also, 55 Cancri e is about 25 times closer to its star than Mercury is to our sun. As a result, the temperatures there are just enormous. On the day side, they're just above 4,000 degrees Fahrenheit, And on the night side, which, by the way, is considered the cold one, over 2,500 degrees Fahrenheit. Doesn't really sound like a good place to chill out, does it? Well, it may not be good for us, but for diamonds, it's just perfect. After studying the planet, scientists concluded that it's a rocky world full of carbon. But this carbon isn't contained there in the form of gas. Instead, it's in the form of graphite. Yes, the same one found in your pencils. And, of course, diamonds. According to some estimates, diamonds can make up at least a third of 55 Cancri E. It can cost about $27 non-million. There are 30 zeros in this number. Can you imagine that? But the most interesting question is, what would such a planet look like? First of all, the thermal evolution and tectonic processes there are completely different compared to our Earth. In other words, the planet should be full of strange volcanoes and some bizarre volcanic activity. Weird mountains and stuff like that. In addition, the planet is probably covered with large clouds of dust, and the atmosphere on it is very dense. Oh, and the weather there is definitely crazy. The researchers are planning to learn about the composition of 55 Cancri E's atmosphere in the future, but right now it's already pretty clear that this planet can't be called habitable. Well, finding life there is theoretically possible, but it's very unlikely. Life on a diamond planet could potentially exist deep underground, for example. On Earth, we've already observed bacteria and microbes that can survive under incredibly extreme conditions. These guys are very resilient. They're capable of turning chemicals into energy and surviving, basically anywhere. So on a diamond planet, life could potentially exist in this form. And who knows, extraterrestrial life may also take forms that are completely unknown to us. Wouldn't it be cool to discover some crystal creatures capable of surviving in the most extreme heat? That would be mind-blowing! And guess what? It's not just 55 Cancri E that's full of diamonds. Other potential diamond hotspots include Pluto's largest moon, Charon, and a Jupiter-style exoplanet rich in carbon found 1,200 light-years from Earth called WASP-12b. Scientists even think that diamonds rain on Saturn and Jupiter regularly. All this was discovered by the researchers from Arizona State University. They claim that diamond planets are not that rare at all. According to a 2020 scientific report, they form around certain types of stars that have high carbon-to-oxygen ratios. They went above and beyond to study these space gems. They subjected carbide silicon to insanely extreme pressures above 50 GPa and temperatures as high as 2,500 degrees Kelvin to see what would happen. And they discovered that under these wild conditions, carbide silicon transforms into diamond and silica. So if you're looking for some diamond bling, you might not have to go too far. You could go intergalactic and explore some of these diamond planets. These exoplanets are unlike anything in our solar system. And who knows what other awesome discoveries are out there waiting for us to find them.
Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet, 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets and the first galaxies in the universe. and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks, and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the Moon. It sounds horrifying, but in reality, the birth of the Moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the Moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chongasite, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the Moon and the first one found by China. Now, it has become the 3rd country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the Moon. We think that there's more helium-3 on the Moon than on Earth because of the solar winds. The sun has been hammering on the Moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the Moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy. Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers have discovered a much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star, AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located at around 531 light-years away from Earth in the constellation of Aurigae. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what's left of the disk will come together to form the elements of the planetary system. Planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae b, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, is forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae b is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae b isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later, they called it GQ Lupi b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Lupi b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called UY Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow manage to place UY Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TUN 618. Its mass is equal to that of 66 billion suns. It was the year 2010. With the help of the Fermi telescope, astronomers spotted something ginormous, something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like Supervoid in Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of the average comet. In fact, see 2014 UN 271, Bernardinelli Bernstein was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah. It won't get closer than 1 billion miles to our beautiful green planet, and it won't happen until 2031. But could there be comets even bigger than that? Who knows, but the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate 2 narrow beams of light, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting the Kuiper Belt. It's a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre, elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin, 40-mile-wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because it looks like a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years. And the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it was formed from another gargantuan star, more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly.
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, A supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
Since 2007, astronomers have been receiving super-strong and ultra-bright radio signals that last just a few milliseconds. Such mysterious flashes are called fast radio bursts. They seem to be coming from billions of light-years away. Not so long ago, researchers were lucky enough to capture a repeating radio burst that flashed 6 times in a row. Who knows, it might help us crack the puzzle of these signals. But hold on, it's just the first mystery on our list. If nuclear pasta does exist, it's the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance is squeezed into spaghetti-like tangles of material. It can break, but only after you apply 10 billion times the pressure needed to shatter steel. That single, high-energy neutrino that hit Earth in 2017 wasn't extraordinary on its own. Scientists observe such neutrinos at least once a month. But it was the first one to arrive, carrying so much information about its origin that astronomers could actually point their telescopes in the direction it had come from. They found out that the neutrino had been flung at our planet around 4 billion years ago by a flaring blazar, a supermassive black hole at the center of a galaxy. Saturn's moon Hyperion is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity which is flowing out into space. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras illuminating the planet's atmosphere. When a team of astronomers at Louisiana State University first spotted this star, they were totally baffled. The object, nicknamed Tabby's star, dipped in brightness at irregular intervals and for odd periods of time. Sometimes the difference in brightness reached 22%. Could it be due to the activity of some alien megastructure? Unlikely. The main theory claims that the star is surrounded by an abnormal ring of dust, which causes the darkening. DJI-SAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone. Unlike other galaxies of this kind, which are usually found in clusters. It can mean that DJI-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Massive objects curve light so much that it can distort the images of objects behind them. When astronomers used the Hubble Space Telescope to detect a quasar from the early universe, they used their discovery to calculate the expansion rate of the universe. Strangely, they discovered that, currently, it was much faster than it used to be. That finding contradicted other measurements. We still don't know if our theories are wrong or if something bizarre is going on in our universe. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star. But this theory hasn't been proven yet. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre, elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most enigmatic thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Dark matter is believed to make up 85% of the universe, and researchers used to be sure it was everywhere. But in March 2018, a team of scientists discovered a peculiar galaxy that seemed to contain little to no dark matter. Later, though, it was proven that this space oddity did, in fact, contain dark matter. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this yet. Planets orbit stars, moons orbit planets, then why can't there be moons, also known as submoons, moonets, and muons? Researchers claim that moons could exist. But the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet.
How is the death of the universe possible if the universe is infinite? The concept of the universe's death is more about its state and less about its size or infiniteness. Several theories predict how the universe could end, but they often focus on the thermodynamic properties, energy distribution, and the fate of matter over time, rather than the universe ceasing to exist entirely. Here are a few scenarios based on current scientific understanding: heat death or the big freeze. This is the most widely accepted scenario, based on the second law of thermodynamics. Over trillions of years, it's theorized that the universe will reach a state of maximum entropy, where all energy is evenly distributed and no work can be performed. The universe would be cold and dead, with all stars burned out, and every bit of energy spread out thinly across an ever-expanding cosmos. Big Rip. This theory suggests that the expansion of the universe, driven by dark energy, could continue to accelerate indefinitely. Eventually, this acceleration would become so powerful that it would tear apart galaxies, stars, planets, and finally molecules and atoms themselves. Big Crunch. The opposite of the Big Bang, this theory proposes that the expansion of the universe could reverse, causing the universe to collapse back on itself into a singularity. This scenario is less favored now because observations suggest the universe's expansion is accelerating, not slowing down. Big Bounce. This theory combines aspects of the Big Crunch with the idea of cyclic universes. It suggests that after a big crunch, the universe could bounce back and start expanding again, potentially leading to an infinite cycle of universes being born, dying, and being reborn. The concept of an infinite universe doesn't contradict these scenarios because infinity here refers more to the spatial extent rather than its lifespan or the distribution of matter and energy within it. Even in an infinite universe, the distribution of energy can become so even that no meaningful activity can take place, leading to a death of sorts in terms of the universe's ability to host life or undergo change. How can energy be distributed uniformly in an infinite universe? If the universe is infinite, then there must be infinitely many regions where energy is not evenly distributed. The concept of energy being evenly distributed in an infinite universe indeed presents a paradox when taken at face value. The idea primarily stems from thermodynamics applied to a more understandable, finite model of the universe. However, applying these principles to an infinite universe requires some nuance: local versus global uniformity. In an infinite universe, energy could become evenly distributed on a local scale, within observable regions, rather than globally. The observable universe, the part we can see and measure, might reach a state of maximum entropy, where energy within this region is evenly spread out. Beyond our observable universe, conditions could vary wildly, but those variations would have no effect on the state of entropy within our observable limits. The horizon problem. This issue is also related to the cosmological horizon problem, which the theory of cosmic inflation addresses. The horizon problem questions how parts of the universe are too far apart to have exchanged light, or any information, since the Big Bang appears to be at the same temperature. Cosmic inflation theory suggests that the universe expanded exponentially in a very short time period after the Big Bang, smoothing out any initial irregularities over a vast region. In this context, an even distribution doesn't necessarily mean perfectly uniform across infinity, but sufficiently uniform within the observable universe due to its rapid early expansion. The role of dark energy. The current accelerated expansion of the universe, driven by dark energy, adds another layer of complexity. If dark energy continues to accelerate the universe's expansion, it could lead to scenarios like the Big Freeze or the Big Rip. In these cases, while locally, within our observable universe, energy might become more evenly distributed as stars burn out and matter spreads thin, the global picture across an infinite universe might be far more complicated and beyond our current understanding. Theoretical limits. The discussion of energy distribution in an infinite universe touches on the limits of our current theories. General relativity, quantum mechanics, and thermodynamics are all based on observations and experiments within the observable universe. Extrapolating these theories to an infinite cosmos involves assumptions that may not hold universally. In summary, when physicists talk about the universe reaching thermal equilibrium or heat death, they're often referring to the observable universe. The concept of an infinite universe introduces complexities that challenge our current understanding, suggesting that the true nature of the entire cosmos could be far more intricate than our local observations can reveal.
If the universe is everything, then there is nothing external for it to expand into. But we know for sure that it does expand. So the question is, what exactly is it expanding into? According to the theory of cosmic inflation, the universe was once filled with large amounts of energy. It was similar to hypothetical dark energy, but much greater in magnitude. It made the universe expand faster and faster. As a result, the universe was getting colder and emptier. And then, after growing this way for a very long, possibly infinite amount of time, most of this energy got converted into matter and radiation, which triggered the Big Bang. The Big Bang was the moment when the whole universe was squeezed into a tiny, super hot, and extremely dense ball we call a singularity. And all of a sudden, when it was less than 1 second old, this tiny ball started to unpack at speeds we can't even imagine. It was so hot that particles were moving extremely fast, crashing into one another and creating pairs with their opposites, like matter and antimatter. When the universe was 1/100th of a billionth of a trillionth of a second in age, it experienced an incredible burst of expansion that we know as inflation. At that moment, the universe doubled in size at the speed of light. And after that, it doubled in size at least 90 more times, growing from a subatomic size formation to a Gulf-sized structure almost instantly. After this burst of inflation, according to NASA, the growth of the universe continued, but it slowed down. As the universe kept expanding, it started to cool down, and matter formed. 1 second after the Big Bang, and the universe was already filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. If we somehow managed to observe the universe when it was just a trillionth of a second old, we'd see that it was the size of Earth's orbit around the Sun. When the universe was a mere 1 second old, it was too hot for nuclear fusion to occur. At that time, its radius was just 10 light years, which is enough to enclose the 9 nearest star systems we know about. When the universe was 1 year old, it was smaller than our home galaxy and unbelievably hot. Finally hot enough to start nuclear fusion. When the universe was 3 years old, it was roughly the size of the Milky Way galaxy. When matter started to dominate radiation, which happened when the universe was around 10,000 years old, the size of the universe was about 10 million light years. It would be easy to think of the Big Bang and the resulting expanding universe as an ordinary explosion, where everything is expanding from a central point. But it's not a good analogy. There's a better one. Look at the surface of an inflating balloon. It'll be a 2-dimensional equivalent of our 3-dimensional universe. The balloon fabric will be space. These dots marked on its surface will represent galaxies. You see, they're moving apart as the balloon expands, but it happens only because the fabric, representing space itself, is expanding. The galaxies aren't moving on their own, and there's no central point for the expansion. The balloon is expanding into the 3rd dimension, and that's where the analogy is getting trickier. Does it mean that our universe is expanding into some higher dimension? If there's no larger multiverse and our universe is all there is, then there's nothing outside of it. Not even a vacuum, which is still part of space. It means there's no point in asking what the universe expands into. If there was a 2-dimensional being on the surface of our expanding balloon, they would be able to observe all distances in its surface 2D world getting larger. But they wouldn't see the 3rd dimension into which the balloon is expanding. The same goes for us, 3-dimensional creatures. We see the distances between galaxies growing, meaning the inflation of space, but we can't perceive additional space dimensions into which the expansion is moving beyond our 3. Even if space is indeed expanding into some higher dimension, our current knowledge of physics doesn't allow us to find out anything about it. It's likely to be beyond our comprehension.